NASA, SpaceX 30th Commercial Resupply Mission Overview. New research and technology demonstrations for NASA are set to launch aboard the agency's SpaceX 30th Commercial Resupply Services mission to the International Space Station. The SpaceX Dragon cargo resupply spacecraft will deliver more than 6,000 pounds of scientific research, supplies, and hardware to the orbiting laboratory. Launch is scheduled for at 4:55 p.m. Eastern Daylight Time Thursday, March 21st, from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. This is the 10th SpaceX launch under the Commercial Resupply Services 2 (CRS) contract, as the first 20 launches were under the original Resupply Services contract. NASA, Space 30th Commercial Resupply Mission Overview. New research and technology demonstrations for NASA are set to launch aboard the agency's SpaceX 30th Commercial Resupply Services mission to the International Space Station. The SpaceX Dragon cargo resupply spacecraft will deliver more than. Launch is scheduled for at 4:55 p.m. Eastern Daylight Time Thursday, March 21st, from Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. This is the 10th SpaceX launch under the Commercial Resupply Services 2 (CRS) contract, as the first 20 launches were under the original Resupply Services contract. Research highlights: plants off the planet. Plants can be used in regenerative life support systems, to provide food, and to contribute to the well-being of astronauts on future deep space. Explorat. Missions. The Photosynthesis in Space Advanced Plant Experiment examines how microgravity affects the mechanisms by which two types of grasses, known as C3 and C4, capture carbon dioxide from the atmosphere. Plants respond to stressful conditions based on their genetic makeup and the environment, said Pubudu Handakumbra, principal investigator with the Pacific. Aim to uncover the molecular changes involved in plants exposed to spaceflight stressors and develop an understanding of the mechanisms of photosynthesis in space. Results could clarify plant responses to stressful environments and inform the design of bioregenerative support systems on future missions, as well as systems for plant growth on Earth. Ensing the sea, the ocean significantly affects the global climate. A technique called Global Navigation Satellite System Reflectometry, which receives satellite signals reflected from the surface of Earth, shows promise as a way to monitor ocean phenomena and improve climate models. KILIC-1, a Global Navigation Satellite System Reflectometry CubeSat for measuring sea ice thickness and extent. NanoRacks KILIC-1 tests using this technique to measure sea ice. The project supports development of space and science capabilities in Newfoundland and Labrador, Canada, by providing hands-on experience with space systems and Earth observation. More than 100 undergraduate and graduate engineering students participated in the project. The most exciting aspect of this project is that students have the opportunity to launch a mission into space, said Desmond Power, a co-investigator with Sea Corps of Canada. It is also exciting to build a tiny satellite that does different things, including contributing to our knowledge of climate change. Reflectometry technology is low-cost, light, and energy efficient. Its potential applications on Earth include providing data for weather and climate models and improving the understanding of ocean phenomena such as surface winds and storm surge, automated autonomous assistance, the multi-resolution scanner, MOS, payload for AstroB tests technology to automate 3D sensing, mapping, and situational awareness systems. Our MRS on an AstroB free-flying robot will create 3D maps inside the space station, said Mark Elmoudy, project lead with Australia's National Science Agency, Commonwealth Scientific and Industrial Research Organisation, which developed the technology with Boeing. The scanner integrates technologies developed by our mining and robotics teams. By combining data from multiple sensors, we compensate for weaknesses in any one system. This provides very high-resolution 3D data and more accurate trajectory data to help us understand how the robot moves around in space. The technology could be used to autonomously operate spacecraft with minimal or no human occupancy, where robots must sense the environment and precisely maneuver, including the Lunar Gateway space station, said principal investigator Connie Miller of Boeing. Other uses could be to inspect and maintain spacecraft and for autonomous vehicle operations on other celestial bodies. Results also support improvements in robotic technologies for harsh and dangerous environments on Earth. Placement of particles. The nanoparticle haloing suspension investigation examines how nanoparticles and microparticles interact within an electrical field. A process called nanoparticle haloing uses charged nanoparticles to enable precise particle arrangements that improve the efficiency of quantum dot synthesized solar cells, according to Stuart J. Williams, principal investigator with the University of Louisville Department of Mechanical Engineering.
7, 6, 5, 4, 3, 2, 1, ignition, and liftoff at a Dragon return to Space Launch Complex 40.
Science and cargo take flight on NASA's SpaceX 30th Commercial Resupply Services mission. Falcon 9 at 1.7 million pounds of thrust, pitching downrange, hearing good calls of performance. Nominal trajectory as Falcon 9 and Dragon arc out to the northeast.
Falcon 9 has successfully lifted off from Slick 40 at Cape Canaveral Space Force Station. And during ascent, we will tilt or gimbal our engines, guiding the rocket into what we call a gravity turn. Through this turn, the vehicle is flying both up and horizontally away from the launch pad. Now, this rocket typically needs to go about 17,500 miles per hour horizontally in order to make it to orbit and avoid being pulled back down to Earth. So moments ago, we did throttle the engines down in preparation for max Q, or maximum aerodynamic pressure, in just a couple seconds.
Max Q.
There was that call out for max Q. And coming up, we have a few events in quick succession, starting with main engine cutoff, followed by stage separation, second engine startup 1, and the start of the boost back burn for the first stage.
And back is chilling.
There's the call out. The MVAC engine on the second stage is chilling in, getting ready for startup. Now, the first of these events is main engine cutoff, or MECO, where the 9 Merlin 1D engines on the first stage will shut down in preparation for stage separation, which is where stage 1 and 2 will separate from each other, with the first stage making its way back down to Earth and the second stage performing second engine start 1, which is where we ignite that single Merlin vacuum engine on board the second stage. Now, the boost back burn will then start on the first stage. This burn helps assist the vehicle flip back around and reorient itself back to land. MECO starting in just a couple seconds.
MECO.
Stage separation confirmed.
And back ignition. Stage 1 boost back startup.
There you heard and saw those events happening back to back. Awesome views of the first stage flipping back around as it performs its boost back burn. Again, we had main engine cutoff of the first stage, stage separation, second engine start on the second stage, and that first stage doing the awesome flip as it starts its boost back burn. Now, this burn is a little under a minute, so we have about 20 seconds left in this burn. In about 3 minutes after that, we will have 2 additional burns on the first stage to prepare to land back at landing zone 1 at Cape Canaveral. We are at T plus 3 minutes and 30 seconds here in today's mission. CRS-30 is SpaceX's
Stage 1 boost back shutdown.
There's that confirmation for the boost back shutdown of the first stage.
Nominal trajectory.
And a nominal trajectory. As again, CRS-30 is SpaceX's 27th launch this year. And we are coming up on the entry burn of the first stage, as well as second engine cutoff. On those live views of the first stage, you can see the attitude control system creating those beautiful puffs of white gas. And that's nitrogen from the cold gas thrusters of the attitude control system. And around T plus 6 minutes and 30 seconds, you should see on your screen the first stage's entry burn. And for the entry burn, we relight 3 of the M1D engines on the first stage, starting with the center engine 9, followed shortly by engines 1 and 5, which slows the vehicle down as it passes back into the Earth's atmosphere. We need to slow down to reduce re-entry forces, which helps us to recover and reuse the first stage. The second stage on the right, you can see beautiful views of the Earth in the background and that Merlin vacuum engine heating up as it performs its burn. Again, we are a little over a minute to the start of our first stage entry burn. You can see the first stage on those live views on your left with 2 of the 4 hypersonic grid fins deployed, helping steer that first stage down as it makes its way back home to Earth. Now you can see the telemetry on the bottom left and right hands of your screen. The right-hand side is the second stage carrying our Dragon capsule, and the left-hand side is the first stage. You can see the second stage speeding up as it is performing its burn, and the first stage is coming back down towards the Earth's atmosphere with the altitude decreasing. Really cool views from the attitude control system of the first stage. Just about 20 seconds from the start of our first stage entry burn, we should be able to see really cool views of that burn from those views on the left of your screen.
Stage 1 entry burn startup.
There is the start of the stage 1 entry burn, and this is a 3-engine burn on the first stage of Falcon 9.
Stage 1 entry burn shut down.
There you
Stage
saw
1 FTS has safed.
really cool views of the end of the first stage entry burn and the
Both
flight
stages nominal trajectory.
and the call-outs for nominal trajectory and the flight termination system being saved. Now the first stage that is supporting today's mission has just performed this entry burn for the 6th time. Falcon 9 is the world's first orbital class reusable rocket, and this allows SpaceX to refly the most expensive parts of the rocket, which in turn drives
Stage 1 transonic.
down the cost of access to space. Now coming up, we have that landing burn starting in just a few moments. There's the start of
Stage 1 landing burn.
that landing burn. Really cool view of Cape Canaveral coast.
Stage 1 landing leg deploy.
Wow, wonderful views of that first stage landing. Back at landing zone 1, looking pristine there, and there you have it.
Guidance.
That landing marks SpaceX's 286th recovery of an orbital class rocket, including the first stage landings for Falcon 9
Stage 2 FTS has safed.
and Heavy. You heard that call out that stage 2 FTS is safe, getting ready for second engine cutoff here in just under 10 seconds.
MVAC shutdown.
There is that second engine cutoff with the MVAC shutdown call out, waiting for confirmation of a good orbital
Nominal
insertion.
orbit insertion.
There is that confirmation of good orbit. It looks like we are on track for Dragon separation in just a few minutes, just before the T plus 12-minute mark. It has been a great launch so far. As I mentioned earlier, today's launch was the first for our upgraded Dragon to be flying from Slick 40 after we stopped flying the older version of Dragon back in 2020. And to support our growing launch manifest, we've made new upgrades to Space Launch Complex 40, including a brand new tower and access arm, which enables more efficient late load operations as well as human spaceflight missions. And with these updates, we are on our way to having 2 launch pads capable of supporting flying humans to space. You can see really cool views of the MVAC engine and the Earth in the background from the second stage. And in addition to flying cargo to support crew on board the space station, SpaceX also enables researchers the opportunity to fly critical science to orbit on Dragon, which has carried over 1,000 research experiments to and from low Earth orbit and the International Space Station since 2012. Enabling research in space paves the way for us to explore beyond Earth and make life multiplanetary. And now we are waiting for Dragon to separate from Falcon 9's second stage. To recap so far, we had an on-time liftoff at 4:55 p.m. Eastern Time. Everything has proceeded nominally so far. Stage separation occurred at about 2.5 minutes into flight, and that was followed by a successful landing of Falcon 9's first stage at Landing Zone 1 back in Cape Canaveral, Florida. That was the 6th landing for that particular Falcon 9 first stage. And for those of you following along, this Dragon capsule has also supported CRS-22, CRS-24, and CRS-27, which were 3 additional cargo resupply missions to the International Space Station. At about T plus 8.5 minutes, we had a successful second engine cutoff, followed by confirmation of a good orbital insertion. The vehicle is now coasting with Dragon attached, and we are just about 30 seconds away from spacecraft separation. We're seeing great views from the second stage with the Earth and the Sun in the background as it prepares to separate Dragon so that Dragon can begin its journey to the International Space Station. Just a few seconds from payload deployment. You can see Dragon floating away there. It's very exciting to see Dragon is drifting away from Falcon 9 second stage there, confirming good spacecraft separation. Now, SpaceX is honored to be a part of NASA's Commercial Resupply Services Initiative to deliver critical cargo to the space station, and we thank NASA for entrusting us with today's mission. For those of you following along, you'll know that this mission marks our 27th of the year. Congratulations to the SpaceX team. We're just in March and we're already launched in partnership with NASA missions like Axiom 3, Cygnus, and PACE, Intuitive Machines, Crew 8, and more. You can check spacex.com/launches for up-to-date missions and schedules. But that will do it for me here in Hawthorne. But I'm handing it over to Gary to take us through Dragon nose cone opening. Gary?
Hey, thank you, Yome. We were following along from here in Mission Control Houston, a wonderful launch of Dragon from Space Launch Complex 40 at Cape Canaveral Space Force Station. Great to see Dragon in orbit and starting its journey on the way to the International Space Station. We're continuing our coverage here in Mission Control Houston, awaiting for the nose cone to deploy. The nose cone is at the very tip of the Dragon spacecraft. Once deployed, exposes the 4 forward bulkhead Dracos. These Draco thrusters will execute the series of maneuvers necessary to raise its orbit and meet up with the destination of Dragon's launch today, the International Space Station. Of course, after separation, it is carrying 3 tons of supplies, including science, as well as some food to the International Space Station. A common question we get is what sorts of treats and food are inside Dragon that the Expedition 70 crew aboard station is awaiting. We did receive word that there is a fresh food kit, including some fruits and vegetables like citrus, apples, and cherry tomatoes inside Dragon right now. There's also 2 crew-requested coffee kits and 60, that's 60 bulk overwrap bags. These are standard bobs containing some standard food menu items as well as some crew preference choices. You're getting a live look at the second stage, now transferring to the control rooms. On the left side, you see the SpaceX mission control teams over in Hawthorne, California that oversaw today's launch and will continue to monitor Dragon on its journey to the International Space Station over the next day and a half. The teams you see there on the right are here with me in Mission Control Houston, the International Space Station flight control teams monitoring the orbiting complex, and of course the operations jointly with Hawthorne, the flight controllers there. Joint operations between the 2 teams you see here will come a little bit closer to when Dragon is in its final approach phase, just about 2 hours or so prior to docking. Docking is scheduled for early Saturday morning. Teams here are waiting for the nose cone to